This is TWIS. This Week in Science, episode number 923, recorded on Wednesday, April 26th, 2023. Why aren't we studying sex in space? Hey everyone, I'm Dr. Kiki, and tonight on the show, we are going to fill your heads with guts, poop, and sex. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. You can have doctors without science. You can have medicine without science. You can have doctors who, without science, recommend medicine unsupported by science. They just need to be clear that what they do is not related to science. What cannot be allowed is doctors generating fake science, which is what we have now in the case of Florida Surgeon General, who altered the findings of a 2022 COVID-19 vaccine study from the mRNA vaccine poses no significant risk to young men to suggesting mRNA vaccines increase risks in young men, a complete opposite of what the study initially found. This is the same individual who is also an author on a separate research paper back in 2020. In that paper, the authors advocated for a treatment method of hydroxychloroquine to treat COVID-19. That research was led by Dr. Zelenko, who went on to sell anti-COVID supplements before dying of COVID at the ripe old age of 49. Some of the other doctors on that paper, well, at least one wound up with a position in the U.S. Department of Health and Human Services during the pandemic. Another one, who's a non-practicing cardiologist, became a guest on the Joe Rogan show promoting COVID conspiracy theories. Another doctor listed as an author went on to invent his own treatment using asthma medication and claiming it had a 100% success rate. Another doctor became a guest of the Alex Jones show and had a list of people, prominent Americans, that he would like to kill in order to end the pandemic. Another is a practicing cardiologist, somehow still to this day tweeting vaccine misinformation. A large number of the members of the study were members of the Association of American Physicians and Surgeons, a political organization that believes, this is their words, that doctors should be autonomous in treating their patients with less government oversight, medical quality standards, insurance coverage limits, and no legal penalties when they make mistakes. So if you have a God complex and you're a doctor, there's an organization for you. Some of the members appeared on Fox News suggesting people should not wear masks during the pandemic to accelerate herd immunity. And on for 57 incredibly unscientific doctors listed as authors who have and likely still do treat patients, real patients. Each seemingly had a motive beyond research for being part of the study, and each wanted to call their ideas science. But I draw the line right there at science. Go be bad doctors if that's your calling, but don't call it science. And don't publish that trash if you don't want it seen here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. Blair, Justin, thank you so much for taking the helm last week while I was away, rubbing elbows with YouTube podcast elites. Ha! Oh my god.
That's awesome. Yeah, it wasn't the same without you, but we carried on. Happy to wave the flag of science.
Thank you for letting me. I got to go to space camp for an afternoon. It was amazing.
Nice.
Wow.
I
That's awesome.
I took a space shuttle to the International Space Station and did science. It was awesome.
You took the space shuttle?
Yeah. Yep. Yes.
I'm so
VR?
jealous.
Yeah. It's
No,
little-
don't drill
Whatever.
down on it, Blair. Just accept it.
Okay.
Wow.
It was fun, but I am so glad to be back here again to talk about science with all of you. Oh my goodness. All right, so this week I have stories about gut systems, nervous systems, and gassy asteroids. What do you have, Justin?
Oh, I've got a bear that turned into a woman. I've got also got stories, some poo pills in the
Awesome.
news. What else is there? Oh, and then I've got we're going to talk briefly about the lunar lander that didn't or maybe did, as well as the most frightening thing I've ever heard about antibiotic resistance. The scariest story I have ever heard related.
I don't like scary. Okay.
related
Blair,
to
what's in the animal
antimicrobial
corner?
resistance.
I'm moving on.
Oh, I have some relaxing animal corner to kind of counterbalance this with some sleepy seals and then well, I don't know how relaxed. Some roadkill. So never mind. I don't know.
Well, we're off to the races, everyone. And as we jump into the science, I would love to remind everyone that if you are not already subscribed, you can find us as a podcast. Most places that podcasts are podcasts. And you can watch us weekly as we stream live on YouTube, Facebook, and Twitch, 8 p.m. Pacific time, Wednesdays. And we are mostly TWIS, but sometimes, like on Twitter, Instagram, and Twitch, we are at TWIS Science. Oh, also on the Universidon Mastodon. But it gets confusing. So just remember that our website is twis.org. That's where you can find all the good stuff. Okay, so it's time for the science. Let's dig in. Since this last weekend was Earth Day, I wanted to start the show with a little bit of earthiness and attempt a little bit of discussion of, you know, the possibilities of living sustainably on this planet. Can we do it? Who's doing it?
Maybe.
I mean,
there a
anything's possible.
Some researchers published in One Earth this past week their work looking at basically the limits of ecosystem sustainability and what they call the attempts to be socially just and also environmentally safe. So carbon sequestration or carbon usage, and then also allowing everyone in their countries to meet their basic needs. The bottom line for this study is that at the current rate of usage of things and how we're doing stuff, only 6% of nations in the world have the ability to be both safe and just in their use and delivery of resources to their
6%.
populations.
Is that by population or just by number? Just pure how many countries?
So it was looking at 178 nations around the world.
Got it.
Yeah, and they used biophysical models and data to determine requirements of meeting needs such as food, water, energy, etc. So they have used frameworks that other studies have used already, but they have developed what they call a biophysical approach for the quantification in terms of ecosystem goods and services. So there's this idea of, you know, the basic limits, the carrying capacity of the earth. How many people can the earth sustain? And we just keep adding people, and we're like, technology is going to take care of everything. It's totally great. Yet at the same time,
and it has a few times,
right? Yes. So they found that 67% of nations are operating within their safe and just space for water provisioning. So 2/3 are getting water to people the way.
Good.
Only 9% are doing so for carbon sequestration and 6% for both. Yeah. So
That makes
anyway,
sense.
there's a lot of work to do, people. Is the bottom line. And the countries that seem to be doing really well, they've got this framework determining what they consider to be the countries that are able to do both the safe and the just. And these countries include Canada, Sweden, Gabon, but not the United States.
Wait,
of course not.
Denmark's not on that list? Oh, come on.
Denmark's not on the list.
Come on.
We're getting there. Yeah, but there's a lot of work to be done, and we talk a lot about. I think the big take-home message here is that we talk a lot about carbon dioxide, and we're releasing carbon dioxide into the atmosphere. We're using resources, blah, 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 but we're not thinking of everything within the actuality of the energy hitting the planet, how we use it currently. It's like we're taking a credit card out on the future that we don't really know how we're going to pay. And our sustainability is very limited at this point in time. So anyway, happy later day, everyone.
List? Hang on a second. Wait, is this a Canadian study? Because there's no way Canada makes that list. They've got the heater on all the time.
But they have a lot of resources, so their ecosystems supply, and they also have smaller population than a lot of other countries, and so the resources to population...
Smaller? Have you met a Canadian recently? These are not small people. Look.
I'm not talking about little, tiny, small people. I'm talking about the number of people.
There's no way that they're using all sustainable energy and doesn't have a giant carbon footprint. Something's wrong. If it's by space, if you're saying, because of look how big Canada is and how few people, and therefore, but otherwise something's not right. Canada made the list, but Denmark didn't. I gotta interrogate this.
This Week in Science, the show where Justin refutes data.
No, I haven't even seen the data.
Sound right?
No, I haven't even seen any of the data. That's the thing. It's that much of an outlier that Canada made that list. That even without seeing the data,
based on very little actual information, Justin. You just have you have like a gut feeling about Canada that you don't like.
Yeah,
that's what this is.
No, he's pro-Denmark.
Canada,
he's pro-Denmark. He's just jealous.
It's just it's the comparative thing here. Like there's just I don't understand how people who are snowbound for 70% of the year could be conservatively using carbon emissions.
Could it be possible that because they are snowbound for 70% of the year, they are more energy efficient because they don't want to lose heat from their buildings?
No, because there's plenty of places in the world that don't have the heater on all the time.
I haven't read the study, but no.
All right.
No.
It just doesn't, it just can't be.
Yeah. Anyway, there is a food, energy, water nexus that is important to consider as we look forward into sustainability for the future. It's not that we can't do it. It's just that at this point in time, the majority of countries are not doing it. And this is not just carbon dioxide. We talk about just carbon dioxide, climate change, whatever. This is sustainability for humanity on this planet into the future. And we need to think more about the way that all of these things work together in a systems management perspective and not just get singularly focused. Yeah. Happy late Earth Day. Anyway, Justin, what do you want to talk about?
Our Canadian in the chat room is pointing out that they a while ago have replaced their cars with dog sled teams. So now it makes sense. Now I get it. How that happened.
And the igloos were well insulated. Yes.
Yeah. Oh, and somebody's pointing out that Canadians, we Canadians are much bigger than you Americans. Okay, yeah, I should probably watch my. Wait, what's the story? What's the first? I'm not even looking at
Bears.
the rundown.
When a bear becomes a woman.
Yeah, this is an interesting story. So this is which is why we're talking about it in the first place.
Yeah.
First people to live in the Americas migrated from Siberia across the Bering Strait. So the story goes, at least over 20,000 years ago, populating then 2 continents from Alaska to Tierra del Fuego, where they ran out of new places to go. Not all of the early settlers were struck with the wanderlust. Some were completely happy with where they wound up and never left. This is University of Buffalo evolutionary biologist Charlotte Lindquist and collaborators using ancient genetic data analysis. They found that some modern Alaska natives still live almost exactly where their ancestors did 3,000 years ago. While examining mammal remains that had been found in a cave in southeast Alaska, a bone identified as coming from a bear was genetically analyzed, and it turned out it wasn't a bear, it was a woman. Dun, dun, dun. That's a big surprise. You're like, oh gosh, we must have contamination. This is coming back. All our results are human.
I feel like bear bones and human bones look very different normally. So
Depends on what the bone is.
Surprising. Yeah.
Depends on what the bone. Yeah. So a lot of human remains, at least I know in the California area where I'm at, a lot of times when they find old remains, they're bovine. How you mix up a cow's bone with a human bone, I don't know, but there's similarities in different bones that can appear to be other things. Anyway, plus the condition may be pretty deteriorated, so you're not working with like a
whole bone.
Yeah, like a fresh bone. Discovery led to an effort to compare this genome to the local community. And so they did. The earliest people had already started moving along the Pacific coast and inland route between ice sheets before the ice sheet path became completely viable. So it's still glaciers across the northern parts of the Americas. Some individual, including this female found in the cave, made their home in the area that surrounds the Gulf of Alaska, that is now home to, I'm going to mess this up, to Tlingit Nation and 3 other groups. The genome from this 3,000-year-old individual determined that she is most closely related to Alaska natives living in the area today. Very interesting. So cooperation between Alaska Native peoples and the scientific community has been a big significant component of the cave explorations that have taken place in the region. The genetic continuity of Southeast Alaska is now thousands of years old. This is the first time they found something that a human remained this old that they could get a genome from that could be linked to that native population. So this is the migration began maybe 24-something thousand years ago. We don't really know exactly when it began. It must have been at least
sounds about the right time frame. Yeah.
It must have been at the very least that we're finding 24, maybe even 30,000 year signs of human occupation down in Central America, Southern North America, Central America. That may be as old as 30,000 years. So there were waves, one of which was about 6,000 years ago. That included the Paleo-Inuit, formerly known, it says here, as Paleo-Eskimo. But Eskimo is considered a derogatory term, so nobody uses it anymore, except every time that they use Inuit for some reason, they feel compelled to point out that they aren't using the word Eskimo and why it is that they aren't using the word Eskimo. Because it's apparently derogatory. Although, when you look at try to figure out where the word Eskimo comes from, it apparently comes from an American Cree tribe, referring to Inuits as either raw meat eaters or folks who lace up their shoes. Jury's still out. Doesn't really matter. We're not using that word. But it does also matter part of the story because they checked to see if there was Inuit influence in the genome, and there was not. So this ancestor of those tribes living in the area is from the much earlier migrations. Fun side that is that I'm glad that they added into the telling of this story in the paper. There's an oral origin narrative of the Tlingit, I'm going to mess it up again, Tlingit people, which includes the volcanic eruption of a local mountain. That mountain erupted, they know, 4,500 years ago. So the people are already tied through oral history to an event older than this ancient one at 4,500 years ago. Now, part of it is that story had to be passed down continuously, generation by generation, for thousands of years for it to make it to the modern day. But it also means that that story would have been going around 3,000 years ago. It had been going around for 1,500 years. It means the lady in the cave likely knew the story as well and could have been telling it to her children.
Yeah. That's cool.
Yeah.
Being midstream of the folk history.
Being midstream of the folk history. And so there's that sort of a strange connection for an oral tradition that goes back that far when you realize, like, it would have been the same story.
Mm-hmm.
Maybe a little bit of game of telephone here and there. You never know.
Yeah. I mean, when you think about it, really, to be part of a culture that has stories that go back so far. I mean, we all have stories, right? There's stories going back through all branches of humanity, but so many times they get mixed up and switched around. But to have cultures that really focus on their storytelling and have it go back thousands and thousands of years, it's amazing.
And I think it might also help if you don't have too many writers in your community.
Right.
So that you've only got a couple of stories, then they tend to probably stick. If everybody's coming up with a new story all the time, then it's like, oh, wait, which one is this? Is this the guy with the one with the volcano? Or is it the guy that's with the, you know?
But these stories can be used now to help us understand our past.
Yeah.
Evolution, human movements, all of the cool things. But then there's the future and where we're going to be going in the future. And there's some stories and thoughts and ideas. Blair?
Yes. So in the future, you might be telling your buddies a story about the time you joined the 62 Mile High Club, huh?
What?
So I just have a real quick story I wanted to bring from Cranfield University. This is a green paper, which is basically just a document that kind of calls scientists to action to invite discussion and approach a problem. So basically, Cranfield University just published this green paper to say, y'all, we gotta talk about sex in space.
We do?
Yes.
Is that the title of the paper?
It should be. It's not, but it should be. So space tourism, it's coming. Some of it's already here. It is a part of our future. People will be going to space for fun, even if it's just for a few hours.
Yeah.
And when people go to space for fun, they will be having sex. I'm not saying
they're going to have
us
fun.
In this room are going to want to do that, but people will. And so this paper is basically just acknowledging that if you take people to space for fun, some of them are going to find a way to have sex up there. And that is a problem, something that needs to be discussed. It turns out, for a bunch of reasons. So,
yeah, I'm sitting here going, but why is it a problem?
So great question.
Because of zero gravity.
No, people will figure it out, but like, why is it a problem?
There's like liability, litigation, and reputational damage related to these things. But specifically, we don't know what happens when conception occurs in 0Gs. Specifically, we don't know what happens. We don't know what happens to the fetus later on. So, A, people will be having sex in space. B, people might be having unprotected sex in space, which could then C, lead to space conception, which is a thing that needs to be looked at. It hasn't been. And so Professor Cullen from Cranfield University, who led the work, said, quote, "Our starting point was a throwaway comment about sex in space. But when we checked, we were surprised the sector has not openly considered the risks. This led to the study." So basically they made a joke about it and they were like, well, but surely they've looked into it a little. And they looked around and went, no, nobody's looked. So there is a strong recommendation that relevant parties involved in space tourism enter into some open discussions talking about risks, mitigations, and create and disseminate best practices for the sector.
Wow. Well, I know there's been physics research and there have been studies, but I think the social science aspects of this are very interesting.
I mean, at the very least, you gotta put some mice in space and get them to have babies and see what happens. The very least.
Have we not done that yet?
I feel like we should have done that. I feel like that's already been happening.
I don't know, but did it happen then with artificial gravity, or did we not chart fetal development over the course of 0Gs, or like there's radiation concern? Like there's all these sorts of factors that most likely have not been measured specifically.
So back in 2017, there was work that showed that sperm that had been stored in space was able to make healthy baby mice on Earth.
Sure.
But that's mice can reproduce after they've been in space.
Sure.
But yeah.
That's the thing. The sex in space needs some study, turns out.
Wow. Yeah, interesting. Because especially if it's space tourism, it's a holiday, it's a short period of time. People are going, they're going to have a good time, and then they go home.
Mm-hmm.
And then what? What happens in space stays in space?
Yeah. Well, okay. And then, I mean, this is also related to the conversation about if you're sending people to Mars.
Right.
And they are spending months in space. They will have sex. So then what? And you may want them to create a population on Mars. Then what? Right? So this is still part of that same conversation. That this green paper is just saying, hey, let's talk about it. Let's figure this out.
Hey.
Nobody's talking about it.
So, yeah, there's so many things. So first of all, just the physical act of sex without gravity seems like that could be tricky. But manageable. Manageable.
Justin, I do believe you yourself said life finds a way. So
it was my uncle, but yeah.
Oh dear.
Well, the other thing, of course, then is the beyond the act. There is, of course, the fluid dynamic containment aspect of being in a closed capsule with no gravity. And, you've seen the astronauts where they're like smooch something out of a tube and then go up and... So there's that whole concept.
So that needs to be studied because if that is a risk factor in taking people to space, then they need to figure out
bodily fluids destroying
for a shared environment.
Yeah.
Of passengers as opposed to a personal capsule in space. This is a very different. And then, if you're talking long-term pregnancy in space, first of all,
that's different. Yeah.
What pregnant woman getting into the later gestational area there wouldn't like to have no gravity for a while.
Right.
On the other
What does
hand-
that do to your ligaments and your muscles and all sorts of things? If you then
They're
come
already
down?
messed up. Actually,
No,
they're
but
already ready for space.
If you
But
had
we've
zero gravity the whole
Yeah.
time you were growing a fetus, and then
Yeah.
all of a sudden you have gravity,
Yeah.
that's bad.
That
Oh,
could
yeah.
be
That's
a
gonna be
really, really
bad.
severe issue.
So-
And we've already shown with bacterial studies and plant studies that when they're growing in space, they figure their way out, but things are different. There are different developmental factors and growth factors that become activated in space because of the low gravity situation. So this could
Right.
impact development of a fetus.
Big time development, and then positioning.
Uh-huh.
Yeah.
Just the little Bambanini
How does it know which way to go?
Yep.
Which way's up,
They
which
like
way's
hang
down?
out upside down for quite a long time.
Oh, they turn
Anyway.
around, and at a certain
in
point, when
theory,
it's time,
yeah.
in
But
theory,
how
it's
will they know which way
how
to
would
turn?
they know, right?
There's no up and there's no down. Then
Yeah.
Mm.
Yeah.
There's no-
This is the thing. There's lots to consider.
There is a lot to consider.
So even if it's just that,
So-
like, oh, this needs to be avoided at all costs, then that has to be considered for space tourism. I almost said sex tourism. That's incorrect. Space
Well-
tourism.
that's
Um,
the next
that
step.
they,
of-
at the very least, you need to include that as a waiver of liability to say, like, this is not something that we encourage. This is ill-advised for the following reasons. You need to say that you will not do this, and if you do this and it results in problems, it is not our fault. So that's part of this too, is that you have to you have to set up precautions, but in the end, humans are going to do what humans are going to do. But you got to at least warn them and protect yourself
yeah.
as a company also from people doing stupid things. So it's,
Hey,
that's part of it,
everybody, we know you're gonna do it, but just know this: we're not in charge.
ill-advised.
Ill-advised.
Yeah. So anyway.
So yeah, still question: why aren't we studying more sex in space?
Mhm. Time to
Needs
do
to
it.
happen. Time to
Mhm.
do it. Yeah. Why haven't we been studying intestines, our guts, more?
I thought we do a lot.
We do. And then you're like, oh, your intestine, if you were to take it out, it would cover the size.
The Grand
of
Canyon. No.
Right, it's huge. It's a tennis court. It's whatever. It's
Yeah.
Tennis court's the lungs. If you spread the lungs out, they're
Yeah.
the tennis court. So
I
I don't know.
just
Maybe
kind
it's
of
a
like-
Rhode Island?
I don't know.
Rhode
Island.
Tennis court is like my default for internal organs getting spread out over the.
The lungs is the tennis court. I think the intestines is if you go around the track. Maybe I don't know.
Yeah, it's our intestines.
Length of a
They're
football
big.
field.
So
Okay.
there's this idea. It's like, it's the intestines. It's this length, and it's fine. Everybody's intestines are like the same. It's great. It's just all good. And apparently, there's individual variation. And we just haven't been taking it into account. And so some researchers from North Carolina State University have published their work in Peer J this last week of studies of the diversity of intestines. Pigs, frogs, rats, humans, all across the board. The intestines comprise varied and very different sizes. So the researchers said there was research over a century ago that looked at variability in the relative lengths of human intestines. But then people went, we don't care. And it's been ignored, pretty much ignored since then. And then these researchers dug into it, and they determined that, quote, from one of the authors of the study, if you're talking to 4 different people, odds are good that all of them have different guts in terms of the relative sizes of the organs that make up the system. For example, the cecum, it's an organ that's found at the nexus of the small and large intestines. One person might have a cecum that's only a few centimeters long, while someone else might have one that's the size of a coin purse. They found other variability. I love these analogies, though. I have my cecum. It's the size of a coin purse. and again, also women additionally have longer small intestines than men. And they think that this might help women withstand stressful situations like lack of food a little bit better than men do, because you have the longer small intestine. It helps you to extract more nutrients. And so this might lead to women's ability to survive better during periods of stress.
Mm.
Yes.
I'm sorry, I missed part of what you said there. So, and it's just because of the way my brain works. You said coin purse, and I immediately thought,
how big?
Who is referencing anything in terms of a coin purse? Like, the generation before ours didn't use coin purses.
We're
you
talking
have to
Seacums.
go back at least one more
Seacums.
for the coin purse to be an analogy that anybody would have any reference.
What's an analogous size to a coin purse, though? I can't even really think of anything that you would use in like 2023 terms that would be similar.
Oh yeah, I don't know what could possibly be.
The size of an iPhone?
An AirPod case.
That's too small for a coin.
That's a little small.
Way too
That's
small.
The size, the length of an iPhone, maybe.
But then, are you talking a Pro or a Mini
big.
or a?
Yeah.
Yeah, maybe
maybe coin purse just has its own niche of size that nothing else is close to. Maybe that's why it's endured.
Don't little kids get their allowance in coin purses still? I feel
what
like
are you talking about? No, they have refillable credit cards.
Oh my god.
Or an app now. See, I'm probably a generation behind the kids today. They probably got an app.
Yes.
So anyway, the
yes, tell me about the small intestine. So the small intestine. So this is also based on the assumption that women can handle lack of food stress better than men.
So that when you get any food, you're able to extract more nutrients from it, and so that makes.
I think that's really funny because if you look at like social media or general societal expectations, I feel like women are always the ones that are getting pegged as being hangry all the time.
Maybe there's a reason. We're just like sucking all the nutrients out of life.
Okay. All right. I don't know.
I have no idea. I'm making things up here. But
Laura in the chat room. Palm of your hand.
There you go. Coin purse.
Palm of your hand. Perfect analogy.
I also want to comment sideline as well. We're just destroying your study, Kiki. This artist's depiction of animals and their guts is a nightmare. And
wonderful.
The frog looks like Kermit, and it looks like Kermit's head has been placed on top of a macabre like chicken made out of guts.
Yeah, I see it. Too.
And I can't handle it, but I take your point that there's variation between species and also between individuals. And
this is important.
That to me sounds like duh.
Well,
because also species have different diets. So
exactly.
You also have different needs to extract nutrients over short or long periods, depending on what kind of food you're eating and how often you eat. Like reptiles and mammals or amphibians and mammals are vastly different in that they process food at different speeds. So a snake might only eat once a week and poop once a week. Yeah. And
or an
we eat 3 times a day.
Right.
Okay.
Yeah. Like one big meal and doesn't eat again for a month.
Yeah.
Would you? Are you suggesting that ancestrally diet-based populations could have different lengths of intestines or configurations of intestines based on thousands of years of diet differences?
Why not? Yeah, coastal communities having guts that are better.
And that's the interesting aspect of this is that form follows function. That is a very, very solid tenet of physiology. So the form, length of the intestine is going to have been led to over evolutionary time by the foods, the environment, all the stuff that all ties together as an organism. evolves. But the individual differences, I think, are going to be interesting moving forward, especially as it comes to medicine. So we talk a lot about the microbiome, but if you put that also in the context of the amount of time or length of intestine that is there for food to be digested and absorbed, that all is going to interplay. And so maybe there is something to do with the shape, the length, the way that the digestive system is formed in between individuals that we need to be taking into our view of how to treat people medically for gut issues.
So how do we measure our intestines?
Right? How do we know? I don't know.
Take better care, because
very carefully.
It's not just processing time, because that is not necessarily directly related to length.
Correct.
Yeah.
So you need to figure. You swallow a string or something.
No.
Figure it out. I know.
Claire,
I'm joking. Come on.
That's a terrible idea. No.
No, but there has to be a way, I don't know, some sort of MRI or something. But if it's so important to know how long your intestines are for specialized care, there's a whole field out there for people, to try to figure out how to measure your intestines.
Right. So getting into this, the fact that they're saying this has been ignored for a very, very long time, maybe this kind of a study is the start that we need to kickstart a bit of investigation into how these diversities impact our health overall. How can we look at it? What can we do? I don't know. Justin, are you wanting to talk about poop now?
Yeah, okay, so here we go. Let's go from the gut to, if we're following with this is researchers out of Upstate Medical University, which I looked it up, is a real university in upstate New York, which is where it got its name. Sounds makety up. I went to Upstate Medical University over. Anyway, researchers there found that compared with standard antibiotic treatment, stool transplantation can increase the number of people who recover from Clostriditis difficile, C. diff, bacterial infections. So this is a condition which causes life-threatening diarrhea.
It's a big deal.
C. diff is particularly pernicious because it can go into this dormant shell-like state, and when it's there, it's almost indestructible. So you can be on antibiotics that would normally kill the C. diff, but if it's in this sort of hibernating state, it evades. It evades everything. It just waits and then reemerges later and reinfects. And so this is also when it reinfects, you probably had antibiotics, right? So you've had antibiotics to kill this. It evaded it and then popped up where there is an open area to fill in its niche because it's like can become the predominant thing there. 77% of people who received stool transplants did not experience reinfection within 8 weeks of the study, compared to just 40% of those who were on antibiotics. So while antibiotics can be a very effective first round against, you have a you have a bacterial infection of your gut. It's not C. diff. It's something else. It's really bad. So you go on to the antibiotics. They also take out the beneficial bacteria. So it takes out whatever is ruining your stomach, plus it takes out the beneficial bacteria. C. diff hides out, comes back after the beneficial bacteria is gone and the whatever it was you were trying to get rid of is gone, and takes over. Okay. And then this is when you get that real serious next round of diarrhea that can be life-threatening. So the standard treatment of C. diff is more antibiotics. So further depleting any beneficial bacteria or knocking them down again as they're attempting to reemerge. And so this, you can already see, this is what you would call one of those vicious cycles.
Yeah, absolutely.
Where the treatment is followed by a recurrent infection and an overfamiliarity with the reading material at your doctor's waiting area. A ridiculous pattern happens in nearly a third of infected individuals. According to the CDC, every year there are around 250,000 C. diff infections in the U.S. alone, causing approximately 12,000 fatalities. In this study, transplanting healthy donor stool into a gut to jumpstart the gut microbes and reestablish the healthy microbiome significantly reduced the risk of C. diff reoccurring, because when it reemerged, there was competition.
Yes, please initiate all the fecal transplant studies. Please. Everybody do it.
Yeah, this was a pretty decent size for fecal transplant. This was researchers examined data from 6 clinical trials with a total of 320 adults that addressed the efficacy and safety of stool transplantation for the treatment of repeated C. diff infection.
And what was the methodology for transplant in this one?
Very careful.
No, it looks like they looked at a number of different studies. So
Yeah.
there's going to be
Okay.
different, probably different methods, but
There were. This is Denmark, Netherlands, Italy, Canada, and the
Okay.
United States.
So it's
there
probably all the above.
Yeah.
There's probably some pills. There's probably some suppositories. There's probably some
Right.
surgery happening. There's probably lots
Yeah.
of things. Yeah.
I don't know if there was any
hopefully,
surgery involved, but-
hopefully not
yeah.
too much surgery. Yeah. Looking very quickly, I'm not seeing anything in the study that looks like surgery, but
But anyway,
Okay.
it's just another good reason to order Dr. Justin's Not a Real Doctor poo pills. Guaranteed, spelled wrong for legal reasons, to
Huh.
fix whatever ails you and make you better at the things you want to do.
I think microbiome transplant is something that we've had such a strong gut feeling about for so long. It makes the most sense. It seems like a potential lifesaver. As you mentioned here, C. diff is a terrible disease.
Potentially lethal. Yeah.
You basically starve to death, right? It's terrible. And so it's always felt like in my bones, like a really obvious, smart thing to push forward through studies to get to kind of medical practice. And I am so happy to hear that more and more studies are happening with it, because that's all we need. We just need to get some data and it will become practice. But that you have to get that middle part done where you go,
Right.
yes, this sounds like it should work. And then you need the proof of exactly how it works and if it works and when it works. And then you can.
And it needs to be done in a regulated way, and it needs to be done, in a safe way, because there have been studies that have shown that if it's not done in a safe way, it can cause more problems, right? So you need to make sure that it is coming, the transplant materials are coming from somebody who's healthy, that you have safe practices in the handling of everything, in the and how it's all produced and put together for the transplant.
One thing that you can't do is do it all in a sterile environment.
Right.
To an extent, because there's a certain there's a certain aspect of it that's by its definition the opposite of sterile.
Yeah.
But is there, for example, like a really targeted, specific, narrow band antibiotic that you would want to feed to someone who is going to be a fecal donor to prevent bad bacteria from getting over, right? So these are the things that need to be figured out. Like, are you just taking a healthy person and moving their entire microbiome over? Are you trying to move a specific band of microbiome over? Are you trying to eliminate bad bacteria and only put good microbiome over there?
So let me give you an
that's
example.
all relative too. How do you put it all together?
Perfect example. Are we going to preserve this entire biome of animals in an ecosystem, or are we going to take some of the animals and put them over here and grab one from over there and put it in and grab...
What you would do if you were trying to preserve an ecosystem is not preserve invasive species, which is basically what I'm talking about.
Right?
No, well, that's...
So you make a healthy, you try and promote the native species. Exactly, which is what you want to do. But if you've got a problem like this, you can't just go... antibiotics, kill the entire biological ecosystem, which is basically what we're doing there. So,
but that's what we do.
Yeah.
That's how they work right now.
That's how
I mean, we don't have, I don't think, a narrow enough band. Otherwise, people would probably not ever have this diff problem in the first place.
But this is what needs to be studied, right? Are there specific bacteria that you want to see?
They're opportunists
versus others, or this is what needs to be looked at. Is my point. Because you need to do it safely. You can't just say, you're a healthy person, I'm not a healthy person, give me your poop. You can't just do that.
Why? That's exactly how Dr. Justin's not a real doctor. Poo pill's not guaranteed to be in pill form.
That's not what we do.
That's how it works.
Oh my goodness. Oh my goodness. Let's move to space very quickly before we finish this segment of the show. Asteroids, comets, meteor showers. What do you know about meteor showers?
They're pretty.
Yeah, but if
it's burning.
So the idea is that you've got
tiny, right? They're just little.
You've got a chunk of rock, or you've got which is an asteroid, and bits and pieces are coming off of it. Dust that ends up we're going through the tail, right? And those little bits, those pennies are
streaks
burning up in our atmosphere. And or the idea is comets that have similar dusty, gassy trails. So we know comets, they go around the sun. Comets we know are like icy, and so they're melting and vaporizing, and there's water and vapor and gas that's streaking behind them, and that's what we see with the comets. There is a particular asteroid called Phaethon, 3200 Phaethon, and it acts like a comet, but it isn't a comet. It's an asteroid, and it is responsible for the annual Geminid meteor shower. So for the longest time, everybody's been like, oh, it's like a comet. It goes around the sun. It heats up. And, but it's just dust. It's just got a tail of dust. And that dust is what our planet's going through. And, whoo, dusty, dusty meteor shower. Yay, exciting Geminids. Well, researchers from NASA have been looking at all of the wonderful tools that they have at their ready these days. NASA's Solar Terrestrial Relations Observatory, also the Solar and Heliospheric Observatory, SOHO, not from New York. They're looking at a whole bunch of things, part of the Sungrazer project, looking at things that go near the sun. They're looking at these images, comets, other things. But these tools have never been made to look at asteroids, meteors, comets. These tools are supposed to study the sun, and they're looking at the images in a completely different way. And they determined that Phaethon does not release a gassy vapor, or it doesn't release a dusty tail. It has no dusty tail. There's no dust. So, number one, if there's no dust, where the heck is the Geminid meteor shower coming from? And why is Phaethon a part of that? We have no clue. Number two, they determined that instead of releasing dust, it is releasing a sodium gas. So it's heating up and releasing a gas vapor. No dust, no physical stuff that should be like debris that we're going through. So everybody is very confused now. Interested, curious, what the heck is going on? Is there some kind of orbit that Phaethon ended up in, that something else was in that was broken up? Maybe Phaethon was part of something else that got broken up. We don't know how Phaethon, which we thought was the source of the material for the Geminid meteor shower, we don't know how it's related to that material anymore. Yeah.
I like
Yay, science.
Grouchy Gamer in the chat room saying it's free salt.
Yeah.
It's salt, little chunks of salt hitting the sodium hitting the atmosphere. But could it be hitchhikers just sort of caught in this? But it
could be hitchhikers. Yeah.
But just not detectable enough, I guess, because otherwise they'd be saying that, hey, we didn't find dust, but we found...
Or Phaethon was big and at one point got broken up and maybe it has that tail because something shot it out somehow. It's in an orbit. It's going. But yeah. And they think...
Motion to rename to Gasteroid?
A Gasteroid. I love that.
I'll second that one.
Yeah. But if you think about it, so Phaethon, the Geminid meteor shower, the material, the debris stream that makes it up is estimated to be 1 billion tons of debris.
No big deal. Just 1 billion tons.
Where'd it come from? What's going on, everybody?
How many Rhode Islands is that?
Right? How does it compare?
Sure.
Exactly.
It's a big number.
I believe that's about 1 billion coin purses.
That would make each coin purse weigh a ton.
Yeah.
All right.
It's got a lot of coins in there.
Bigger than the palm of my hand, for sure.
Yeah.
All right. So mysteries in space, isn't it? We keep looking. And the more we look, the more questions we have, which is fantastic. We love it. This is This Week in Science. Thank you so much for joining us for another episode, and we hope that you are enjoying the show. If you do love joining us every single week, I do hope that you head over to TWIS.org and click on the Patreon link, because that's how we do support this little show here. So click over there and click on the Patreon link. Choose your level of support, $10 and more per month. We will thank you by name at the end of the show. Thank you so much for your support. We really can't do this without you. All right, coming on back now with more This Week in Science, and it is time for Blair's Animal Corner.
With Blair!
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Oh, I don't know what that sound was, but you know what?
I have no idea.
I'm going to take that as a sign that I need to tell you about Roadkill. It's an oncoming semi, what we heard. So it's that time again to hear a study that happened because researchers were stuck in their homes in 2020. They had to figure out what they could collect data on and what they could do with it. And you know what? Cardiff University and their Road Lab, it's in Europe, in the UK, they used data of roadkill records to assess 19 wildlife species most frequently involved in vehicular collisions to see what changes there were in road mortality during 2 major lockdown periods, March through May 2020 and December 2020 through March 2021. And by comparing the lockdown rates to the same time periods in previous years, it's in 2014 through 2019, pretty sizable data set, they were able to identify the traits that put species at higher risk of becoming roadkill. They found that there were fewer records of nocturnal mammals, fewer records of animals that visited urban environments, and fewer records of mammals with greater brain mass, as well as fewer records of birds with longer flight initiation distances found in roadkill during the pandemic. Species that have several of these traits, like badgers, foxes, and pheasants, are therefore more likely to be hit by cars and have the highest mortality rate in normal traffic levels. So they've benefited the most from the lockdowns, and so suffer most during normal times. By those measures, they were able to see what kind of you could do to prevent future roadkill instances once traffic returned to normal. Overall, across all species, wildlife vehicle collisions were 80% lower during the lockdown. Seems right. There were not a lot of people on the roads. But so this can help inform wildlife conservation. Who needs an overpass? Who needs an underpass? Who needs slower driving in certain corridors during certain times of year? So this kind of data, I mean, it's one of those things that, like, what can you do during the lockdown, and what can you do when you come out of lockdown when you haven't collected normal data for a year or two?
Comparisons.
You could do comparisons, but if your whole thing is you're the road lab, this is actually great work to do because it can help inform conservation decisions and road planning in the future. So this is, not surprising information that came out of this, not earth-shattering, but I think it's a really good reminder of ways that we can take existing information, roadkill data, and turn that into real actionable conservation outcomes, which I think is cool.
I think it's very cool. I think the data that has come out of it actually is quite interesting. Aside from the, hey, people drive less, less roadkill.
Yeah.
But the whole concept of what kinds of animals are more likely to become roadkill, like large-brained animals, less likely to be roadkill. So this is brain size is usually related to mass, right? That's the relativity, but at the same time, what else is going on there that's leading to these animals not becoming roadkill?
Yeah. No, absolutely. And so, are there little tweaks you can make to city planning or road laws?
Yeah.
Or are there new structures you can build that can alleviate these issues? So
or like different times of year. Can we do different things?
Absolutely. Yeah. Like, are there certain times of year that this is a 15-mile-an-hour road, and then the rest of the times of the year it can be a 35 or 45-mile-an-hour road?
75. Let's go for it.
Yeah. It's an Autobahn it, right? Yeah. Anyway. And then I have my main story for the animal court. I really wanted to have some time to talk about this.
Cool.
Elephant seals. They're so cool. There's so much weird stuff with elephant seals. Like, I can't even start to explain all of the amazing science that exists in relation to elephant seals. They are some of the deepest diving mammals. They dive over a mile underwater, which is insane. They have specialized eyes to prevent their eyes from popping into their head from pressure. There's so much. When I was in school, we went and we did metabolic studies on them because they dive for 2 hours. How does a mammal hold its breath for 2 hours? Well, scientists have been working on that for decades, and there's lots of good explanations. Basically, they slow their metabolism down and just process oxygen really slow. But there's so much biologically going on with them, not to mention just their whole mating structure and all sorts of other things. Just elephant seals. They're really, really, really cool. But this is a new study adding to the many ways that they are just these specialized, amazing animals. This is from UC Santa Cruz. And they wanted to record brain activity in free-ranging wild elephant seals to look at their sleeping habits. That's because when they're on the beach, and they're like either growing up, they're young, or it's during their mating time or their molting time. It's all kind of overlapping seasonally. They sleep about 10 hours a day. And that's what we usually see when we Google elephant seal. We see them loafing around on the beach. But when they are at sea for months, they can be at sea for 8 months straight. They sleep about 2 hours a day. So researchers are really interested in when are they getting this sleep, how are they getting this sleep, and how are they surviving off of so little sleep. So they went to some wild elephant seals, and they fitted them with these like swim caps, basically. They put them they put an electroencephalogram, or EEG, that records brain activity on wild elephant seals during their normal diving behavior time, with a neoprene head cap over it. They also had a small data logger to record signals, and then they recovered the system when the animals came back to beach at Año Nuevo. It's basically the same sensors that you'd use for human sleep in a sleep clinic, and they're removable, they're flexible, they're adhesive, they attach to the cap, and it's mostly protected from water, despite the crazy pressure and amount of time that it's underwater. So it doesn't disrupt the signals. In addition to the EEG, they also carried time depth records, accelerometers, and other instruments so that they could then compare what was happening in their brain and with sleep to seal movement, to correspond that with the brain activity. When are they sleeping? When are they at rest? How deep are they sleeping, right? And so the recording showed that they go into a deep sleep stage known as slow wave sleep while they're diving underwater, and they maintain a controlled glide, almost like a corkscrew down. Then they transition into rapid eye movement, or REM sleep, and at that point the sleep paralysis makes them kind of just drift, and their natural buoyancy is negative at that point when they've gone deep enough. Yeah, you get to watch this this video. If you're listening, check out our show notes. You can watch this seal kind of meaningfully swim down, and then all of a sudden they hit kind of slow wave sleep, and they kind of start to drift and fall kind of sideways, and then they hit REM sleep, and they do this corkscrew pattern downward as they are completely like wonkily upside down and kind of sideways. They just let gravity take over as they are pulled downward. And then after about a 10-minute cat nap, elephant seal nap, they wake up and can forage along the ocean floor. And then they'll surface later on. They're all good.
That's amazing.
Yeah.
This is wild.
Such a crazy adaptation.
Yeah. So one of the things to consider here is that elephant seals are actually at their most vulnerable when they are close to the surface, because that's where sharks are, that's where killer whales are, orcas are. And so when they're at the open ocean on the surface, they can only sleep for a minute or two. Well, they can't really sleep at all. They can only surface long enough to breathe, and then they're back underwater. They're not comfortable sleeping. So they don't get to sleep until they've reached this area of the water column where they don't have many threats.
Predators. Yeah.
Yeah. And so that's when they're like, oh, I'm safe. I'm deep enough. Conk. And then they kind of go into this spiral downward. And
it's also interesting that they're spiraling downward, because you'd think that their buoyancy with all their fat stores and everything would keep them up, but somehow they're continuing to go down. So they're releasing air. They're going like they're getting deeper, which is
So it sounds like it depends on the depth. There's a depth at which they are neutrally buoyant,
right?
And then deeper than that, they become negatively buoyant.
There's an aspect of that too that it's curious, that corkscrewing might limit the speed of the descent.
Right.
Absolutely.
Right. So that, like, because divers do some level of this not to get bubbles in their blood or whatever it is, the horrible, awful bends.
The bends,
things
yes.
that happen. Yeah. So I wonder if part of this is also strangely timing that descent properly, so that if they they did just go straight down, would it cause a problem? But having this corkscrew motion where it's
right,
because you would think you'd want efficiently as possible, which maybe this is. Get to the bottom.
But it's efficient in the sense that it allows them that time to rest, which they wouldn't be able to do otherwise, because they're in zones where predators are also inhabiting.
Yes. Yeah. And so this is really interesting because they've had dive records for a while that show a constant dive So they've assumed, well, they have
They were
to be
just-
sleeping while they're diving. There's no other way to, when else can they possibly sleep? So they just kind of slowly sink in while they sleep. But they didn't know any of the specifics of it. Now they know exactly at what point they hit REM sleep, and it is at this corkscrew moment. So there's actually a specific
Cool.
connection here between the place that they're the safest, the moment when they become negatively buoyant, and the moment at which they let themselves kind of succumb to full sleep. So, of course, this is important just because it's really cool. Like, what the heck? Like, add it to the list of crazy things that elephant seals do. But also, of course, it is important for conservation. And it's because, as the researchers point out, I think it's really interesting, there's a lot of pressure and emphasis in the conservation conversation going towards protecting animals' feeding time. But there is not a lot of
For sleep
protection on sleep time. Yes, exactly. So if there's a specific space at which, if we're thinking about like marine protected areas, and there's a specific part of the water column or a specific type of environment that is conducive to sleep at specific times of year, again, you know, there's like temporal variables are important. Is that something that needs to be protected just like we would protect feeding or breeding spaces? It's a really interesting question.
I would like somebody to protect my sleep. That would be
Same.
great.
Yeah.
Right.
Yeah.
But the ability, number one, to be able to do EEGs on these animals while they're in
Yes.
water, to go get this data is just amazing. And yeah, understanding this now is a new step in understanding how these animals exist in their ecosystem and how we can work, if we want to help them.
Yeah. Yeah. I mean,
But how does this evolutionarily, how does a system like this even get started?
yeah. So I think you're awake
eaten.
until you die.
Yeah.
And then
Like-
some individuals figure out how to catch 10 minutes here or there.
Yeah.
They survive better. And the ones that figure out when and where is most advantageous to fall asleep survive the best. And then that becomes selective pressure, right? So obviously not sleeping at all, you're not going to be able to pass on your genes. That's not sustainable. Yeah. So there has to be a way to do it. And if you're falling asleep on the surface and immediately getting eaten by a shark, no babies for you. No more DNA, right? So,
yeah,
there you go. I think
it's already such an intense number of adaptations to just be able to do the dive,
and then add this.
Oh yeah,
and then have this whole other layer on top of it.
Right. But I encourage you again to look into the myriad of ways that this particular species is hyper evolved for deep sea dive. That is their whole thing.
Yeah.
You think the elephant seal's whole thing is that big old nose? No.
Nope.
Their whole thing is they are the deepest diving mammal, to my knowledge. I could be wrong. No. I think they are the deepest diving mammal on the planet. But so that is an extreme amount of evolutionary pressure that is going to show up in all these different kind of aspects in an animal's physiology.
Yeah.
So.
Awesome. Evolution.
I love it. Elephant seals. Everybody do yourselves a favor. Do a quick Google. Read through that Wikipedia. Maybe I should do a short. Maybe I'll do a short someday about elephant seals. I love them so much. Yeah. Also, just Google
an ode
juvenile elephant seal pictures, because as crazy as the adult males look, the juvenile elephant seals, I think, are the cutest pinniped. Marine mammal biologists, fight me. I think they're the cutest.
Fisticuffs. All right. Moving from animals, Justin, tell us a story about, bacteria and resistance.
Yeah, well, you really don't want to hear this story.
I didn't want to. I know.
Unfortunately. These are researchers out of Oxford, UK, which also I had to look up. That turns out that's also a real university. They've investigated the evolution of antibiotic resistance properties of antimicrobial peptides. So antimicrobial peptides are something that is it's a natural antibiotic that all life forms have in some form or another. This is in humans, it's part of our innate immune system, meaning it's not like a reactive learning thing. It's just compounds that will kill bacteria if they make it into our cells, into our blood, or into our system somewhere. So, long time ago, they isolated some of these from bacteria, from a bacillus strain. And it was used for quite a while in China because it turns out if you give it to chickens, they get bigger. And they also fight off infection. And so, hey, this is great. Let's give this to all the chickens. And something bad happened, which is there became a outbreak of E. coli that was resistant to it. And so that resistance actually started to affect humans and the livestock. And so this really bad E. coli then went worldwide, went global. So they stopped using antimicrobial peptides, AMPs, for agriculture. And they're still used quite a bit because they're that last line of defense against a multi-resistant bacteria or microbe. So colistin is an AMP that was derived from the bacillus that was part of that big outbreak in China back in 2016-ish. Or early 2000s, I guess it was. It was banned in 2016. These researchers had a little bit of a... They were looking at this and they thought, well, that's interesting. So it became... This E. coli strain became resistant to the peptide, antimicrobial peptide that was derived from bacillus. But, well, gosh, that's conserved throughout the animal kingdom. We have that in us, a version of it, an AMP, in our system, our blood systems that is fighting this. So if it can become resistant to it when it was used as an antibiotic, would it also have gained resistance to our innate immune system?
Oh no.
Here's what I need you to think of.
Oh no.
You have an infection and you add an antimicrobial agent to it.
Yeah.
Right? It kills that infection. It kills that invader. Okay, now that invader starts to become resistant to it, so it doesn't work as well. So then you find something else and you apply it, and maybe that works. Great. That's resistance. This is overcoming a resistance that is a natural part of your immune system, not some secondary invasive combination of what is that arms race of microbes fighting each other or overcoming a chemical that attacks it. This is our innate immune system that this has gained some level of resistance to. So they went and tested it. They found that using AMPs found in humans and animals against this E. coli, this E. coli with this new gene, this resistant gene, increased its resistance to natural AMPs in innate immune systems by 62%. In a blood serum experiment, the researchers found high levels of resistance to the human serum, showing that this one strain of E. coli, at least, that they tested, had been trained to avoid our innate immune system. the takeaway from this is using this thing that is so conserved throughout the animal kingdom, to use that as an antibiotic in livestock or anywhere else, creates the possibility that you could get resistances to this from things that aren't currently pathogens. You could train microbes out in the environment to become invasive to humans and all living things.
I mean, it's not like we're going, hey, here's a treat. I mean, we are kind of, but not on purpose. It's not like training a dog or an animal. But yeah.
So normally, these you got to think of these also working in, you know, that like you've got to take your antibiotic treatment to the end.
Till the end.
So normally, if one of these microbes gets invasive, ends up in our blood, something like that, it can't leave, and the work will be done all the way. So there is no chance for it to go out and do a horizontal gene transfer, or some of them survive and now they're going to reproduce. It's there till it's gone. It's caught. We've captured it. We're this lab experiment when it gets into a body. Placing it out in the environment allows things to train on it before they get stuck in that lab environment of the body. It allows them to build resistances in populations. It allows them that then once they find themselves in that body, can overcome the system. Horribly terrifying. Antibiotics to a whole different level, that we would be training an external population of pathogens or currently not pathogens, because whenever it gets into a human body, we don't even notice it because we kill it right away because we've got this innate system that's conserved from bacteria to humans.
But that's the point right there. So we have this innate system that is conserved. And so we have a lot of peptides that are very similar to cows, to chickens. Like we've got peptides that are very similar. This is, yes, as you said, an arms race. And this is something, yes, that has been going on much longer than you and I have been alive.
Yes.
So, yes, we should be concerned about the possibility of training bacteria or other pathogens against these very specific peptides. But yes, at the same time, we also shouldn't think that these bacteria, E. coli, which we've been evolving with for all of time, that these interactions haven't taken place already. But, you know, there's...
Yes.
It's an arm.
Absolutely.
Right?
Oh, absolutely. Absolutely. But you don't tell your secrets. You don't share your secrets en masse.
Right.
Hey, we know there's an arms race. We just want you to... We got the blueprints right here of our next weapon system. We haven't built it yet, but we're planning on it. And this is... Oh, it's got a couple... So you can see it's a giant orbital, round, spherical, planet-destroying thing. It's only got one weakness. If there was one vent right here, if you shoot a little torpedo thingy in there, it blows up the whole thing. Other than that, though, it's perfect.
Yeah. No, I take the point. I totally see the point of this and the importance of this study. I'm just saying that we shouldn't overplay the significance of it. There is a balance to be kept.
Yes.
Because, yes, we have been evolving with E. coli forever. These peptides, many of them are in common with lots of our relatives on this planet already. Yes. So, we don't want to share the plans. This is dumb. Yeah. Let's not do that.
62% more resistant from this one strain.
Let's not do that.
No.
Can we have new antibiotics yet? Can we figure that out? I really would like to figure that out.
Well, the other thing is, like, it's one thing if it overcomes this too, because this is our last line of defense right now.
Yes.
It's another if it doesn't even care. And can attack our bodies with it. That's the other thing. It's just we need a completely different way to attack this arm. We're gonna lose this arms race because we're bad at it.
No, we're getting
Alrighty.
better. We're learning. We're figuring
Okay.
out how to, use the phages that the bacteria like to use to fight each other. So we're learning the phage
I'm being asked for a happier note
defense.
to end the show here. Well, at least my section of it. This isn't really so much of a story as just to update the Lunar lander spacecraft. Japan plan to land on the moon. May be on the moon. They don't know.
Was Schrodinger's lander or what?
So everything was going fine.
We sent it there.
They sent it there. It was above the moon's surface. Only, pretty close to the surface. 90 meters above. Pretty close. And then, lost contact completely. They saw the craft was picking up speed, which it wasn't supposed to because it was supposed to have a reverse thrust kind of a thing to slow it down. It was accelerating towards
Probably
the moon.
not reversing.
Oh, smush.
Yeah. No, we don't know.
Most likely smush, kaboom.
The thing I'm curious about is, can't we just not? The part I couldn't figure out is, why can't we just look? Like, don't we have the ability to see the surface of the moon from the planet Earth well enough to kind of know where it was landing and take a look?
Not
You gotta send
necessarily.
another rover over there
Mhm.
to approximately where you thought it happened. But then you're just gonna end up with a pile of exploded rovers just on top of each other. It's just gonna keep happening.
Anyway, space travel is tougher than you think.
It's
That's
hard.
all I'm
Even
gonna
to
say.
the
So
moon.
even if you want to go be a moon tourist, go have fun. Just understand that you may be watching the moon, you may be getting closer and closer, and then next thing you know, that was it.
Bring a trampoline. Problem
And now
solved.
you're moon detritus.
Oh, detritus. Such a beautiful word.
And I love the word. No, trampolines on. Who needs a trampoline on the moon?
Sounds great to me. I mean, you have less gravity, so you can get some real air. It'd be pretty fun.
Or maybe it's the opposite. Maybe the trampolines don't work as well. That's a great. Now forget sex in space. Now I want to know if trampolines work in space.
Oh,
Well, they would
better.
work. It depends on gravity. It depends on all the forces. Of course, trampolines would work in space, but you need to have the thrust that goes one direction to have the rebound the other direction.
I'm not saying
So,
space.
on
I'm
the
saying on the
moon.
moon. On the moon.
Yeah, on the moon.
work.
I want to know what a trampoline is like on the moon because I feel like it would be very disappointing.
I agree with
initial
you. That's why I said,
Okay.
why do you need a trampoline
Oh,
on the moon?
because
It's
got
already
it. Because
built.
the
It's
down
gravity.
pressure's not as much, so you
Yeah.
you wouldn't really push it. It'd just be like
It would
stepping
just
on
be-
anything
you'd
else.
be walking.
I
on
see
it,
what you're
just
saying.
like- yeah.
Interesting.
Okay. Let's talk about brain stuff. I got a couple of brain stories for the end of the show here. Researchers have been looking at the brain. They like to do that. Do you know about the homunculus?
You mean like a creature that you make in
Nope.
in fantasy? That
Nope.
no,
Nope.
Is that a word
Okay.
that means something that's like even bigger than super gigantic?
Nope, that's not what that means either. No, the homunculus is the little person. I mean, the little man in your brain. Researchers forever and ever and ever have been like, oh, our motor cortex, our sensory cortex, it maps to the human body in some very interesting ways. And we've had this imagining of the homunculus is kind of starting at the toes, and then it goes and to your feet, and then it goes all the way up in your face, and places that need more nerves have bigger representation within the brain. And so really the homunculus is this terribly distorted idea of what a person looks like represented in the neurons in the brain. And they found this by
Giant
sticking
hands, tiny back, kind of a.
All right, let's
that
see it.
picture.
Come on, I know you have a picture. Let me see it.
I do have a picture, but the thing is, this particular new study that was just published in Nature this last week, they have determined that there's more involved in the motor cortex homunculus than has previously been considered. So whereas we used to consider, it's the classical ideas, there's a map of the body in the cortex and it's weird looking and some things are really big and other things are really small. It depends on how many neurons are involved. There is, based on this new fMRI work they've done, a new kind of context, what they're calling the integrate isolate model. And this model has to do with there's certain actions and things that we do where it's not just the motor cortex. Like when we think of how motions take place, there's this very steeped in dogma idea of how it works. It goes, okay, I have an idea in my brain. The idea in my brain goes to the planning area, the premotor cortex. And the premotor cortex goes, it's a great idea. And it shoves the information to the motor cortex. And the motor cortex says, nerves, act. And then you go, boop, boop, and you move your finger. Or you bend your knee. Or you do any number of motions. But it's been this idea that, hey, the homunculus is the representation of everything. And if we look at it, in an fMRI, it should be very one-to-one. You move your finger, the motor cortex nerves for the finger light up and get excited. Boop-boo! But that's not what they found. And so they found that there's some overlap of those very specific one-to-one things, but more so, there are multiple regions of the brain that are involved in planning, that are involved in pain, that are involved in just taking context of the whole system and the environment and the motion itself. So the motor cortex is integrated with the rest of the brain as if it were part of a system and not just acting all by itself.
That's how the brain's supposed to be, isn't it?
Yeah.
Surprise.
That's why, like, if you get brain damage, it's not like you can't use your fingers anymore all of a sudden.
Not necessarily.
But everything else works fine.
Yeah, and there are instances that we've seen over and over where particular areas of the brain get damaged that we think, oh, they're never going to be able to do this again, and then they're able to.
Yeah.
People are able to surprise us all the time. Our brains are plastic, but they're also very interconnected.
Isn't there if somebody loses a limb, say somebody loses a hand, right? I'll keep that graph up there for a little bit.
Yes.
Let me see. I'm gonna see if I can find it a little bit better. So somebody loses a thumb, okay? And so there's no information coming from the thumb anymore. There's no sensory information coming from the thumb. The part of the brain that was there waiting for signals from the brain
now
gets
wants
taken
signals.
over. And then like here you have neck, okay, right, is next to thumb. So what could happen is you could go like this to your neck and feel your phantom thumb because this part of the register for this part of the brain is now taken over that space that used to be connected. Like there's really strange sensory interactions that can happen if one section is lost and sort of wants to keep doing its job, but it now has to go work for the neighboring part of the brain, I guess.
Exactly. Yeah. But even beyond that, there are other cortical regions that are involved and influence the motor cortex. Whereas previously it was like, if the signals get to the motor cortex and the motor cortex fires, you're going to move. But now they understand that there's actually a lot more integration happening. And your homunculus is not the homunculus you thought it was anymore.
I don't like it. I require a story that is less terrifying, that has a less terrifying graphic, please.
Dr. Key, you really, we had horrifying antimicrobial news. We had it's all been roadkill and icky strangers having sex on your trip to space.
Well, hopefully they're not strangers to each other, unless that's their thing. I don't know.
But I'm just saying, I'm assuming that when I get to go to space, it's not going to be like, Mr. Justin, your capsule is awaiting for your personal ride into space. I'm going to be in there and coach, where like people ever like shoulder to shoulder.
And guess
going
what?
To space.
There'll be a bathroom. Where do you?
And the people, I know, but then things float around. Anyway, it's been a horrifying show. Kiki, what can you do to save us?
Well, we're going to talk about the understanding of nervous systems and evolution. So let's go
That
back
sounds
in
good.
history to people first looking at nervous systems under a microscope and coming into the idea of like, what is the nervous system? How do things work? And there's a 19th century scientist, Santiago Ramon y Cajal, working with Fridtjof Nansen. And they came up with the neuron doctrine. The neuron doctrine is that neurons are individual cells, and that's what they are. They're just cells. They're neurons. Look at them go. And then Camillo Golgi came around, and he's like, well, nervous system. You can't just have individuals in a system, so they're going to touch each other. These neurons touch each other. They influence each other. It's a continuous network. And then we found synapses, and that confirmed the whole idea that, oh, these individual neurons actually touch each other, communicate as a continuous system, and it's amazing. We have a nervous system. But where did this nervous system come from? How did it evolve? Researchers just publishing in Science this last week have been looking at comb jellies. Cute little comb jellies.
The jellies that aren't really jellies.
The jellies that aren't jellies. Exactly. And so these jellies that are not jellies but are very, very cute and little, they were easy to look at for these researchers. They're like, well, let us take a look at what's going on. We're going to add some fluorescent dyes. We're going to take a look at what's happening in these, what happen to be early evolutionary ancestors of ours. So we're related to them. We have relatives that go way, 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 way back to the same place historically and in evolutionary time. So the idea that we can look at these comb jellies, we can look at their anatomy and get an idea using 3D electron microscopy to see what's going on in their nervous systems, that it might give us an idea of how nervous systems in general evolved. Well, what they determined is that ctenophores, they don't have nervous systems. They have neural nets. They have nervous nets. So what they have are neurites that have combined together. And so in essence, are one single neuron. And so this is challenging our understanding of what a nervous system actually is. The reality is they have multiple neurons that connect in a way that is more net-like than system-like. So instead of being like our nervous system where we have these neurons touching neurons, they have neurons that are connected and net-like over the entire surface of the organism. Nice. And so the question is, how does this net-like structure really work as a system? And if it's working that way as a system, why didn't we keep it that way? And why do we have the nervous? Yeah. Why do we have the nervous system that we do today?
Yeah.
So it's a very interesting finding that has not been seen previously, and I think it's going to be interesting looking forward for comparative reasons. It's going to be evolutionarily interesting, and additionally, considering our look at AI and neural nets and machine learning, how the kinds of intelligences or systems that we can create, that we use biology to inspire us to create, how is that going to inform us? So there's some really interesting stuff going on there.
Like, would it be better to move from a neural net to like a node-based system, which is right? And or would
kind
that actually be way worse?
Yeah.
Because that would mean that the AI would be way more smart. I don't know. Anyway.
Or when you've got node-based stuff, is it less resilient?
Right.
Like, if you lose a node, how does the rest of the system work?
Right.
so is there some aspect of the evolution of our nervous systems and the plasticity of them? We can lose a neuron and continue functioning. But in the case of these neural nets, like, is it less resilient, and does that influence it?
Well, it just seems like it would be uncompartmentalized, right? So,
right.
Yeah, what would their homunculus look like?
Right. Right, because the difference between, it can be really weird, like the difference between touch and smell and vision, like that we have, which are sort of these separate ways that the brain processes the information, the sensory input. All of these would be in the same note, I suppose, to a neural net. Like it would be very difficult to differentiate what was causing the activity and the way that our brains and our neural systems are set up to have all this compartmentalization in even larger nodal is it nodal or module activity that's taking place in different parts of the brain. So instead of synapses where we have these things butting up against each other and communicating, what if they, like, all of our nerves just really grabbed on and held hands, right?
So that's what I want to see too, is like Tinetophores, comb jellies are
Thank you for pronouncing it correctly.
Yeah. Hey, you'd have to take my zoologist card if I got that wrong. Anyway, they're such their own little phylum. They're their own little phylum, just comb jellies. So what I want to know is, across the animal kingdom, who has a nerve net? Who has it? At what point did it disappear? Did it appear at multiple times and then disappear? Is there some weird convergent evolution where unrelated kind of phyla have it? I'm so curious. Was this a predecessor to what we currently have, or is it just a different way of having?
Yeah. Is it just different?
I don't know.
I don't know either, but it's, a fascinating...
Let's find out.
Yes.
On episode 2000 of TWIS.
Absolutely. We'll just keep on going and going and going. We've come to the end, yes?
Yeah.
Wow.
All the science for this week, everybody. We've made it. Thank you all for listening. We appreciate you being here and being present and talking and chatting in all the chat rooms. Love that you're here doing that. Thank you to Fada, who's not here tonight. He's out doing an improv comedy show somewhere here in Portland, which is pretty awesome. Thank you to Identity 4 for recording the show, Rachel for editing the show, Gord, Arnlore, others who help keep our chat rooms very happy, good places to hang out. Thank you for all of your efforts there. And of course, thank you to our Patreon sponsors for all of your support. I would love to thank Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, George Corris, Pierre Velazar, John Ratnaswamy, Carl Kornfeld, Karen Tozy, Chris Wozniak, Dave Bunn, Vigor Shefstad, Hal Snyder, Donathan Stiles, aka Don Stylo, Ali Coffin, Reagan, Don Munda, Stephen Albaran, Dale Myshak, Stu Pollock, Andrew Swanson, Fredis 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, David E. Youngblood, Sean K. Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, aka Zima, Ken Hayes, Howard Tan, Christopher Rapin, Richard, Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkan, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele. Thank you for all of your support. And if any of you would like to support us on Patreon, head over to twist.org and click on the Patreon link on next week's show.
We will be back Wednesday at 8 p.m. Pacific time and Thursday for the second show, 5 a.m. Central European time.
One show. Just one show, same time. One show, same time.
Well, because there's one that's at 5 a.m. on Thursdays, and there's one that... Well, you can figure it out.
The Earth is round, Justin. And
time zones.
It's anyway.
Time zones.
Yeah.
All right, we'll get to that. We'll cover that one on next week's show, and you can tell me how to.
Sorry. Do you want to listen to us as a podcast? Maybe while you walk around your local aquarium staring at comb jellies. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to the stories are available on our website, www.twis.org. You can also sign up for a newsletter, perhaps?
Yeah, who knows? It could show up. You never know. Just bam, there it is. You can contact us directly also, but don't email me about what the deepest diving mammal is, because I looked it up and there are 2 whales that dive deeper than elephant seals. So that's covered.
Oh.
So you don't need to email me about that. I got it.
Yeah.
Corrected. But it's the deepest diving pinniped. Regardless, you can email me that, I guess, but I've got it. I have that info now. Regardless, you can email Kiki and tell her how wrong I was at Kirsten@thisweekinscience.com. You can email Justin and, I don't know, send him gifts at twistminion@gmail.com. Or you can email me, but not about that, at blairbaz@twis.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be sent up into space on a tourism flight, and I don't know what's going to happen there.
Uh-oh. Well, but after your space trip, you can tell us all about it on the Twitter, where we are at TWIS Science, at Dr. Kiki, at JacksonFly, and at Players Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes due in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week in